Catch you a little tune there. All right, so here we go. So we have this. They start us off like this. They've already got the shape and everything, and they say, all right, this is what's called an objective function, which we'll get to real life. I don't know if we're getting to it now today, but for sure Thursday to show why you even do that in the real world. These will be very much real world problems. Anyway, but for now, we have one more like learning how to turn the wrench. One more tool we're gonna get the hang of before we're ready for the real world stuff. So here we go. They're giving me that function, and they're saying, hey, the graph shows find the max and min values of the expression. Yeah. So what they want me to do is they want me to find the coordinates of all those corners, like this one right here. What's the coordinates of that? X comma y comma sort of thing. Remember that? Which one is that? That's over 2 up 3. X, y. Remember the x is over 2 up 3. Everybody see that? Remember x is over, y is up. All right. So let's try the next one. What's the coordinates of this point here? Can you tell? Over 9 up 4. If it was bigger, you could see it a little bit better. In fact, I could probably make them here. Yeah, great. 2, 3, 5, 8, boom, boom. Who needs to guess? There they are. So what do you do with them? You plug them in one at a time. Let me go over here and write them over here. So 2, 3, 5, 8, 8, 7, 9, 4. You guys watch me do that the whole time thinking, what, is this a trick question, Mr. Heron? They're right there. What's the problem? All right, so this is X and this is Y. You just plug them in one at a time. You're going to take the biggest and the smallest as your max them in. So first plug in the 2 for X and the 3 for Y. What is that? 12. 12 plus 6, 18. And then plug in the 5 for X. And let me change it up. Then next one, plug in the 5 for X and the 8 for Y. Does everybody see what I'm doing there? That's at 30 and 16, 46. That's a bigger total. Y'all tracking with me? Or am I just talking to myself up here doing the Charlie Brown teacher voice? The wah, wah, wah. That's good. Next one, do it again. So now you're going to plug in 8 for X. Right, this is X, this is Y. 7 for Y. What's that? 48 and 14. 58 for 9, 62. Finally, the last one. Plug in 9 for X. And 4 for, what's that? 54 plus 8, 62 again. Interesting. All right. So what's the highest total we got? 62. Got it twice. That's the max. What's the lowest total we got? 18. That's the min. That's what they want. By plugging in those corners into the function, the 6x plus 2y, it's called the objective function. Want the max, want the min. Highest answer we got was 62. Lowest answer we got was 18. That's all they want. That'll be how we end the problems, the real life problems that we do in this section. So they're kind of helping us handle the end so that we can do the whole thing. Good on that? Just plug them in. Okay, so here's what we're really about in this section. Here's a problem. Oh, actually, they're going to get real in 7.3, so that'll be Thursday. So here's what we're going to do. Here's stuff. So we have a bunch of those inequalities. They want you to set up all the inequalities, do the graphing, and then when you're all done, you're going to find the corners and plug them into this thing. All right, time is short. Let's move along. So the first one is 5x plus 4y greater than or equal to 20. The second one is x plus 4y greater than or equal to 8. So here we go. Jump the 5x over. Negative 5x plus 20. Good so far? I'm just gonna get y alone, like we always do. I'm just graphing right now. Just doing what we just did for our last hour. Just gonna get y alone, find the 2 dots, make the graph, do the shading, all that same stuff. Divide by 4. Here we go. There's y alone in that one. Let's do the other one now. flip the x over. And divide by the 4. Eight divided by 4 is 2. Good to there? Got y alone in both cases. Ready to graph? If you're okay with that, I'm going to go to fresh screen. Need a little more room. Number 7 here. What was the first equation? The first one is y greater than or equal to negative 5, 4, 6 plus 5. The second one is y greater than or equal to negative x over 4 plus 2. Okay, let's graph both these on the graph. So, oh, and actually, you know what? When I do the graph, I don't need anything but the first quadrant. Why? Because these bottom two conditions, x and y greater than or equal to 0, that means I only need the first quadrant, upper right-hand corner. So I'm not even going to put onto my graph anything but the upper right. That's all you need. All right, here we go. How do we graph? You start at up 5. 1, 2, 3, 4, 5. And then what do? Rise over run, rise over run, down 5. 1, 2, 3, 4, 5 over 1, 2, 3, 4, huh? And then connect the dots. I'm going to connect them just like that, with nothing more. Even though a line really goes forever, I only care about stuff in the first quadrant because they told me x and y greater than or equal to 0. Am I going too fast? Am I making sense? See how that's just what we did before? I started at 5 and I went down 5 over 4. Now the purple one, start at 2, right here at 2, and go down 1, right? Rise over run, down 1 over 4, right there. So that one will keep going. Is that good? It's a shaky purple line, isn't it? It's not very straight. It's all bendy. It's bendy. There we go. So everybody see what I'm doing? Yes. Right? So for the purple one, I started it up 2, went down 1 over 4. Red would start up 5, down 5 over 4. Got my 2 dots, got my 2 lines. Now, that's all old stuff. What's the new part now? The new part is where's the shading? The shading, notice what it says, greater, greater. What does that mean? Above, which means everything out here that's above both the lines. Nothing under any of the lines. Do you see that? Greater is out that way, right? Okay. So I've got a like a shape. What are the corners of the shape? Right here is a corner, right here is a corner, and somewhere over there is a corner of the shaded region. Do y'all see that? Those are corners of the shaded region, aren't they? So you have to find the coordinates of those corners. Like, what's the xy coordinate here? What's the xy coordinate here? And what's the xy coordinate there? You got to find those. And then once you've got them, you have to plug the corners into the objective function, which they gave you right here. Z is 9x plus 7y. Z is 9x plus 7y. And they either want the highest or the lowest. They won't want both. What do they say? Max. Says, oh, no, it does want both. All right. Real life, they don't want both. But these little make-believe ones, they're going to want the minimum and the maximum. So that's what you got to do. You got to find the coordinates of those 3 green dots, the corners of the shaded region, plug them into this thing, find the max, find the min. We're out of time.